So everyone, maybe you can raise your hand and then come here and then give me the answer. I want to review and use all of the parameters, all of the unknowns to derive what we need. Or maybe we can review a little bit. We can review some of them. Okay, first of all, okay, before we start, we need to define these unknowns. We need to define all of the unknowns. If we have a transmission line, okay, this transmission line has the length L. How long it is L, okay? The length, we have the transmission line L. This transmission line has the characteristic impedance Z0 and the propagational constant beta. Those Z0 and beta can be determined by the geometry or the material of the transmission line. I think we are very clear about Z0 and the beta so far. And this is the length of the transmission line. Okay. We connect this transmission line to a load. The load has an impedance ZL. Okay? We don't have any problem so far. Those are just the unknowns. First of all, we define the position. The position here, the end of the transmission line is Z equals to 0. Z is where it is. Here is Z is 0, okay? We use the coordinate just only in this direction, and then at this point, Z equals to 0. Anyone has a problem? No? Okay, so at here, because the length of the transmission line is L, so in here, Z equals to minus L. No problem. Okay? Okay. So, we can use telegrapher equations we derived at the beginning of chapter 2. Telegrapher equations. We can obtain the structure of your voltage and the current on the transmission line. The voltage of this transmission line on this transmission line is VZ equals to V0 plus times exponential minus J beta Z if this is a lossless transmission line. Okay? If this is lossy transmission line, we will use gamma instead of the J beta plus V0 negative Z. Okay? And this is the result from the telegrapher's equations. These two equations are telegrapher's equation. Okay? So, first of all, okay, 2 point first. 2 point is easier question. Anyone raise your hand, you can get 2 point. What is the definition of Z0? Anyone? 2 points. Raise your hand. Okay. And right now, tell me what's the definition. This is the characteristic impedance. We usually use 15 ohm of the transmission line. We use a 15 ohm transmission line, right? And I want more. This is 1 point only, and equals to no, no. This is not correct. You need to have the definition precisely to understand this question. You need to define this carefully. Anyone has a different answer? You didn't get it right. So, no, me first, and maybe you next, okay? Come on, check it out. This is not exactly what is the definition. And equals to okay, wait a moment. Tell me what are those notations? What is this? What is this? What is this and what is this? You need to tell me that to show me you understand. Anywhere? You can speak in Chinese, I can translate for you. He said this is the input voltage. Input voltage, output voltage, input current, output current. Can you say that precisely? I need an exact definition. You obtain 2 points from these two, but I need to ask more people. What are the definitions of VO plus, IO plus, VO minus, and IO minus? Anyone? 2 more points. What are the definitions? Can anyone answer my question? What are the answer of that? You should tell me. No, you can. This is the question you need to answer. Yes, 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 yes. Okay. Can anyone give me other answers? Okay, you try. If no one want to, do you want to try? We use these two equations for many weeks, right? But you don't know who they are. So ridiculous. You don't know what are them. Okay, tell me what do you think? What are them?
入射波。
Where?
电压跟电流。
Where?
上面那条的长度线。
Come here. Use the whiteboard. You need to define. Another transmission line? You can use my transmission line. This answer is correct. But I cannot give you point because you didn't take my class. V0 plus is the voltage, the positive voltage to the load at Z equals to 0. And the V0 minus is the voltage at Z equals to 0, leaving Z0. Also at Z equals to 0. How do you know that? How do you know? Look at these two equations. If you assume Z equals to 0, then you can get those 4 terms are 1, right?
Yes.
So this is the positive voltage at here. This is the negative voltage at here. Also, this is the current here and the current here. Okay? Okay? So none of you totally understand what are they. That's the reason why you don't understand. This is an easy question. I will ask you more. Well, I want to ask you more questions. Okay, actually you can get 2 points. Only you can get 2 points from that, but you should try harder. More. What is the reflection coefficient? Anyone? 2 points. You think they are easy, but your problem comes from you don't know them exactly. Okay? So today I try to clarify your knowledge, clarify your concept. Anyone? 2 points. Okay. Just give them more points. Okay. Can you give me, this is not definition, this is the result. I want, you are correct, but I want a definition. Can you tell the definition and the result? This is the result we are going to derive. What we derived this result last week, right? You remember that, that's good. But what is the definition of the refraction coefficient? I mean definition. No, wait. I want definition. Yes. So, is this, okay, good, 2 pi. But I want to ask you more questions. Okay, stay. Wait. Okay. Gamma, the reflection coefficient, is at which position? Z equals to everywhere, or what is the definition of your gamma? So everywhere, Z equals to, okay, 2 pi, okay. This is the reflection coefficient at Z equals to 0. So, in my slide, in my PowerPoint, in the textbook, maybe they didn't write it clearly, but the important thing is, if you define this one, actually, this is the reflection coefficient at Z equals to 0, okay? So, this is the ratio of the positive voltage over the negative voltage. This is a ratio of this term over this term. This is the phase, right? And this is the magnitude. If you look at the reflection coefficient at this point, of course, the result is V0 minus over V0 positive, right? If you add this point, of course. But if you regard your transmission line like if this is a new ZL, your ZL is an original ZL plus we put one more transmission line to this one. You know, if you put a transmission line, your ZL will become new ZL, right? So the green box is your new ZL. Okay? Now, your reflection coefficient at this point will be changed. We define the general reflection coefficient as your Z, the reflection coefficient gamma of function Z equals to the whole voltage over okay, it is more general. And your reflection coefficient can be at any position, not only Z equal to 0. Okay? So come back to okay. More. What is the definition of ZL? Anyone? 2 points. Raise your hand. What is ZL? Okay. Yeah. Definition. Yes, that's correct. It is, wait a moment, I want you to write on. It is the voltage of the transmission line at the position Z equals to 0, right? So this one equals to, use these two equations. What is V0? Equals to, 就是 right now. What is I0? Yes, just give me an equation mark. Equation. Equals to. Oh. Okay. This is the definition. Okay, good. Very good. This is a definition. Okay. So, at this point, on your transmission line, your voltage divided by your total current, this is your total voltage because your position Z equals to 0, so your total voltage is this one, okay? And this is your total current, okay? Use this equation. Z0 equals to V0 plus Z0 minus I. Okay? First, you change IO plus IO minus to this one, use this one. Use the definition of characteristic impedance. You can change this one to V0 plus divided by I, right? Oh, Z, sorry, Z. Okay? And very good, you are listening. Minus V0 minus over. Okay? Use this. Okay. Then you use this one. We change, actually we did this last week already. We change this one to gamma okay? Okay, everyone. I did this again actually. So we did that this next time. This one, you just organize. You multiply everything and the clear file you can get. Right? This one becomes this one. You just times, you multiply Z0 and the times everything you organize. Okay? And this result is the same as what we discussed in the chapter 1. Use the wave we have different media. Okay? And then this one is we have not use the Z0 is a wave impedance when you use the wave in the chapter 1. Okay? So this is a story we already discussed last week. This is the impedance at Z equals to 0. We are going to have more stories. Today, we will try to derive the impedance at the beginning of the transmission. This is the question we try to figure out, the important question. If I have a load, ZL, I connect this load to a transmission line. Because our frequency is very high, our impedance will change at this frequency. Because frequency is very high. If the frequency is 0, of course, the same. Right? If frequency is 0, it's very low, it's DC. Just connect them. Of course, voltage will be the same. But if the voltage, the frequency of the voltage is very, very high, we can use the telegraph equations. The voltage at this transmission line is different. So, what is 2.0? What is the definition of the Z in? Anyone? What is the definition of V in? Z in? Anyone? 2 points? If you answer already, you can answer again. Can anyone? So Z in, you can erase it.
minus 负号，一个 L。
I see you got a point. Every detail you need to be very careful.
负 L，负 L，
负 L，
负 L，负 L，
你的位置，
负 Z
你的括号也是的位置。
Yeah, you cannot put something like, oh, it's okay. No. Can you use my notation, please? Can you use my notation? Notation on the phone. Don't change the notation.
I 呀 I，
Yeah, use the capital one.
写法。
Okay, the same as when you do research. You need to do all the notations the same. Don't change that. If you change that, it means it's different. Okay? Okay, good. 2 points. He saved you 2 points. Okay. So, we want to obtain your input impedance Z in, which equals to the total voltage over your total current. Okay. And when he tried to write down, you feel like, oh, minus L is weird, right? Because minus, we usually use the positive signs. So, we can do that. If you change the notation, you don't use Z, you use L. And the L is the minus Z, or Z is minus 0. This one may be easier, okay? So, if I use this notation, how can we change? 2 points. Okay, anyone want to change my telegrapher's equation? This is easy. 2 points. Anyone? Okay. Change your definition, change your telegrapher equation from these 2 equations by using L. Yes. Use blue color. No, just erase the original one. I want to erase. No, okay. Yes. Okay, change it this time. Yeah, thank you. You got 4, right? Okay? Oh. Which one?
I O 那边负 J 下面那个应该是正 J， 因为负 L 原本是负 J。
最左边
就是他们一定都是带负的，
函数带负，
又要带负，然后最后变成下面那个
正的，正的，没有错啊，是左边的底，它只是左边的改一多化，
这边
对啊，负 L
我只是全部换成 L 而已啊。
可是它后面一定都是带负的，
对啊，
对啊，
换成 L 不是带。
那这边 Z 就带负，我为什么是？
应该是负，
不是，它就是一个变成一个新的 L 的代数啊，这样是对的。对对对，就直接换成 L， 然后只有后面是这样子。哦，没有直接，不是直接 L 没有
L 等于负 L，
如果你全部对 L 等于负 Z，
哦 ，Z 等于负 L， 就 L 等于负。
This notation just tell us V is the function of L, or V is the function of Z. That's it. You don't change everything. If you change everything, it means it doesn't. This is just tell you this is a voltage, and it is a function of L. That's it. You don't change this one. Okay? So this is correct. Okay? So now your voltage become a function of L. L is the length of this transmission line. Okay? Okay. Now we can start to derive. As you write down, then we will use all of those definitions and equations to derive what is Z in. Okay. Is that too much for you guys? Too much? Yes, okay. Yeah, maybe it is too much because you didn't say you understand that. Because they spent 1.5 semester to familiar with all of them and you understand, but this is your first time, so it is normal. But if you can understand, that's good because it means you are the chosen one. Okay, let's take a break and we will do that later.